Okay, the next part we will be looking at the formulas of the different elements or the different compounds. Okay, so formulas, the small number or the subscript represents how many atoms of each element is chemically bonded in the compound. So for example, H2O, right, this 2 is the subscript or the small number. What does this represent? This represents that there is 2 hydrogen atoms bonded to 1 oxygen atom. But this 1, usually we don't have to write, so we just write it as H2O. Okay, so you have to know this is 2 hydrogen chemically bonded to 1 oxygen atom to form H2O water. Okay, so no number means 1. Okay, when an element forms a compound, its name will end with IDE. Okay, what do we mean by this? So for example, the most common salt compound in the kitchen is your salt. Okay, salt, the name is sodium chloride. So look at the periodic table. Element sodium is number 11. So the symbol is Na. Okay, chloride actually comes from the element chlorine, which is element number 17. So chlorine became chloride. Why did it become chloride? Because my INE changed to IDE. Why did it change to IDE? Because it now forms a compound. So your name will change. Now the salt in the kitchen is called sodium chloride, NaCl. Okay, for example, in another example, we also can have carbon dioxide, right? So carbon comes from element carbon, but oxide comes from the element oxygen. So oxygen, when the name changed to IDE, the name itself changed to oxide. Okay, so over here, when we name some of the compounds, right? Mono means 1 atom, di means 2, tri means 3, and then tetra, T-E-T-R-A, means 4. Okay, so common example, carbon dioxide. So carbon, right, just 1, and then di means 2 element, oxygen. Okay, so carbon dioxide is CO2. Another example, carbon tetrachloride. So tetra means 4, it means carbon bonded to 4 chlorine atoms. Okay, please know this is also very important. Under your periodic table, we have what we call the monoatomic atoms. So elements that exist as single atoms are monoatomic. Okay, monoatomic means if you draw the picture, they exist as 1 atom by themselves. So we have to know in your periodic table, the group 0 elements are always monoatomic. Okay, group 0 elements, there's another name for them called the noble gases, and they always exist as monoatoms. Okay, for example, you can never have helium as He2. Helium will only exist as He. Okay, they will never form bonds, and they are actually quite unreactive. Okay, so helium can never be He234. Yeah. Same thing, this is very important. We need to know which are the diatomic molecules of the elements in your periodic table. So you know your group 0 elements, they exist as single atoms. Okay. The other elements over here, for example, we have to know your hydrogen, H2, oxygen O2, nitrogen N2. These are all common gases, and they all exist as 2 atoms. They will not exist as 1, they will not exist as 3, 4, 5. Okay, it will always be 2. That's why we call them diatomic. Okay, and then all your group 7 elements. So group 7, there's a name called the halogens, right? They will always exist as 2 atoms. So if your first group 7 element is your fluorine, F2, Cl2, Br2, I2, and so on and so forth, you will not have F3, F4, F5. It will not exist as F only also.